Hi, we're just waiting for everyone to get here before we'll start in a couple of minutes. Hi and welcome to the Solid Edge Tools for Design webinar by Edge PLM. I'm Tom Harris and with me is Andrew Coatsworth, and we'll be answering any questions you may have towards the end of the webinar. So please use the questions pane in the dialogue there, and we'll get to those questions at the end. What we want to look at is what tools Solid Edge has to provide you to get your products to market quickest. We'll be having a look at a SquareBot 3D printer because, well, 3D printers are becoming a lot more commonplace in manufacturing. Now, we'll start off with part design, move into part drawing and assembly design, followed by assembly drawing. So that's just what we'll be having a look through today. Now, we'll start off with part design. Obviously, you need to capture some basic information. Now, this can be traditionally from other parts in an assembly or from the real world, i.e. not in the office. And then you need to transform that information into an actual design. Solid Edge provides you with a number of tools to do this. So we'll just open up Solid Edge. You've got a number of areas that you can learn Solid Edge. All of these are built into Solid Edge and available for free. We can have all our normal templates and then we can open a part. I'll just open up the SquareBot, which is sitting here. Now, this is a nice little 3D printer. Obviously, it's got a bed and a frame, and the extrusion head moves side to side and up and down, and the bed also moves backwards and forwards. I can just, I'll just quickly, we've got various options for if you want to do presentation style, things like reflections and textures that just take the look of the model to the nth degree. And we can also move these things around. Now, I can move them around in a number of ways. If I edit the actual relationships, then you see most of the rest of the assembly becomes ghosted, so I can see exactly what relationship I'm editing. We can also edit it using variable tables, and variable tables can be sorted, and you can work with them quite simply. I'll just start by changing the Z height. So that lifts it up. Notice that the cable holding the counterweight changes height and unwraps from the spool. And notice as well that if we enter a value too large, we can set limits and things like that. If I enter a value that's too large, it gives us a warning. So I'll just fiddle with some of these, and you'll see that all of the cable guides all edit, and it all the model works quite nicely. It's a very flexible model. And we've got a lot of flexibility here. However, there's a couple of parts that are missing and the design is not quite complete. We need to design an end cap for these extrusions. To do that, I'm going to show you another tool, which is actually an app that you can use on an iPad or a phone. Now, the reason I want to show you this is because very often CAD systems are limited to just the desktop computer. When you go out on site or out to where the products are actually being made, you have no way of capturing your design intent and the key dimensions. So Solid Edge or Siemens have come up with a tool called Catchbook. This is run on various iOS or Android devices, and when you start up, obviously it gives you some various help screens. I just want to start up a new file, and I want to create or just sketch from a photo. Now, you can take the photo in the app. In this case, it's a photo of the end of the extrusion. And I just want to get the basic shape and some rough initial dimensions. You can see I can just draw over the top of the photo. What you may not be able to see, and I'll do a little bit more later on so that you can, is it's actually converting my hand strokes into specific lines and arcs on the screen. Now, oops, you see I've left those grouped. I just want to ungroup and move the drawing down a little bit more. I just need to delete that edge, and whoops, I deleted the photo as well. I can put that back in, and I'll tap on the edge, and you see, simply by tapping I can show the key dimensions. By double tapping I can edit those same dimensions. So I've got quite a high level of control over the sketches on this iOS device. Now, this can be used as a key way to input or gather data to put into my CAD system. Oops, didn't mean to do that, just delete that. So it's quite flexible and easy to use. Now, I just need that image, so I'll just place the image back in again. Scale it up to fit on the lines that I've already drawn. And I'll just make sure I deselect. I want to add an additional circle just to fit inside. So I'll just sketch that, and I want to make note of the approximate size of the edge. I'll just click on that circle, grab the diameter, because that could be a little bit bigger by the looks of the screen there. So I'll just key in maybe 45. That looks about the right size. So I'll just move that, center it into the part, and I'll just move this down again to check that that's looking about how I want. Yep, I'm pretty happy with that. Just by pinching it, it closes it, and I can now drag it onto a share icon, and it asks me how I want to share it. I've got DXF, I've got image, I've got PDF. In this case, I actually want to share it as a DXF, and I'll say OK to that. It goes away and generates the DXF from this drawing, and I'll just email it to myself, for example. I could use Dropbox, I can use a number of different ways of sharing and getting this data back to the desktop computer, but in this case I'll just do a DXF. Send that, and that heads off back to my desktop PC where I can open my email and save it. Now, this is quite critical because it allows you, it links your desktop work with your field work, and it means there's no translation or redoing of the work that you do in the field to your desktop. How do we do this? Well, we'll have a look at this next slide. We're using synchronous technology as a key for this, and what synchronous technology is, it's a combination of what we believe is the best of history-based modelling with the best of direct modelling. So back in Solid Edge, I'll simply open up the DXF. We've got various file formats we can open. The DXF I have actually modified slightly in between taking the video because I realised I forgot to add a side view. Now I need that side view, well I wanted that side view, because that shows a little bit more how you can also work with, for example, AutoCAD data. The DXF comes in. First thing I'm going to do is check. Now this is 110 mil. Because I was working off a dimension, typically I would have actually put the correct dimensions on, but this time I know I've just got the correct scale. Well, sorry, incorrect scale, correct shape. So I want to create a 3D model. Now I know my dimension was 110, but I want it to be 30, so I just type that into the scale. Then I select my first view and select my second view. What Solid Edge is going to do is it's going to use these and create those sketches in 3D, lines them up quite nicely. I just want to move this sketch back to line up with the back edge of my part. And then what I'm going to use is the synchronous technology side of things, just simply to add material onto my body. Do a quick dimension check, 30mm, that's scaled correctly. Just need to pull this cylinder out. I can either add or subtract, and I can just tap the spacebar to toggle those as well, just to make it nice and quick. And then this side panel, I didn't actually put the width in, I just guesstimated. Looks like 2mm will probably do for that. And then I just need 4 of these all the way around to go into the sides of the protrusion. So I can simply pattern that all the way around. There's 4. And I don't need that dimension in there. So I've now developed, a very quick look at the part. I may need to, or I may want to create a thin wall. I'll just do a thin wall of 2mm. Note it only takes out that middle section. However, I also need this to be manufacturable. I'll probably do a casting or something like that. So I'll just now remove some of the faces and just do a small angle on this part, and this will make it quite a easily manufacturable part. Now I'll just add a couple of rounds as well, and you can see that I'm actually focusing more on the design than the tools for the design, and that's one of the philosophies of Solid Edge, is it's basically gets out of the way of your design and just lets you focus on what you're doing. So then I want to save this. Now this is quite useful. It has inbuilt an option to check document identity and uniqueness. So you're not going to get duplication of document names if you don't want that to be the case. So it's quite a useful little tool there. So that's saved my part. I can now apply a material, and I think we just apply, looks like that one will do. That's just a plastic. So what we've shown you very, very quickly there is the best of both worlds. Next, I don't actually want to show you part drawing, so I'll just skip on to assembly design. I'll come back to part drawing. We want to be able to design in context, eliminate interference, and we want to be able to edit parts in the context of the assembly. So we'll just come back to the assembly, and I want to, well, first of all, we've got to place the new part into the assembly. So I can browse to directories, or I can just use it straight out of the open documents. And I simply want to capture the fit of this part. I want to make that face onto that face, F for flip if it's the wrong way around. And because of the draft on this, I'm not actually going to be able to mate the side faces with the side faces of my part. So it brings up an error and says, no, we can't do that. However, we have a number of tools, and the one I want to show you at the moment is a center plane relationship. Now, we can do either single or double center planes. In this case, I want a double center plane. Specify 2 faces that are either side of the center plane, and then I can simply select 2 other faces which define the second half of the center. So now I simply need to select the next components that I want to mate this part up to, and grab the faces that we want to mate to as well. You see how quite quickly and simply I've placed that part perfectly in position, even though it's got complex draft angles. Now, does it fit? Well, let's do a check interference. You can see it's highlighted some areas of interference. So maybe I wasn't quite precise with my drawing or the way I positioned those parts. I didn't put any dimensions, I just went by eye. I want to be able to move this face over a little bit. So using a steering wheel, I simply grab it and move it over. You can see it's moving symmetrically because it's maintaining that design intent to the edge. You see it's done that on both sides. I can do a quick interference check again to confirm. No, there's no more interference between these two parts, so it's a nice snug fit. Alright, we've got quite a lot of these extrusions, and I need to be able to place these on the other end as well. Notice I don't have to select the additional relationships all the time. Okay, I can come and grab the next relationship. Oops, sorry. Solid Edge still isn't immune to someone pressing the wrong button, unfortunately. So I'm going to place additional relationships, so I just simply select the faces again and say how it's defined. Now notice the quick pick that I'm using there means I don't need to keep on rotating this model. I can select the faces needed without any rotation. Now I've got two parts on this extrusion. I want to be able to capture these parts and put them on all of the extrusions. Well, Solid Edge gives you a tool for that as well. It's called Duplicate. And everywhere I see this extrusion, it's now going to put those two caps in exactly the same way as I placed them on the first cap. So I can also deselect members if I don't want them to have caps, like the side members, and that's gone and placed caps everywhere. However, remember how this model is quite flexible. I can move things up and down. How does that work? Well, because the extrusion's moved up and down, the caps move with it. So it's a very, very powerful tool for duplicating a pattern of components, regardless of whether it's in a regular pattern or, irregular, as is the case here. Now, we might also need to do a little bit of extra design. We've got three components here that form a foot. I'm just going to isolate this display, which is a very, very quick tool for cutting down what you're looking at. Now, it looks like the bolt is all done, so I'll just hide that out of the way. And I want to go in and edit this silicon foot, and we're going to put a sort of a mounting lip into it. So I'll just quickly draw a circle, make it about 2 mil, and I'll add some dimensions, nice and easy, 2 mil there, and I'll just make that, for example, 0.75 up from the floor. Then all I've got to do is select this, then I place the steering wheel in the middle and start to rotate. Note it cuts out by default. If I just tap spacebar, it adds, type in 360, that's done. I'll save my parts, and I'll just add around a bit smaller than that, 0.25. So now I've got my lip, which will provide a nice positive fit into the plastic base. So I close that, come back, and I can see my plastic base. I might need to just make the lip a little bit wider in order to fit in. I just edit the torus. No, I've got a minor and a major. I just need to increase the major diameter refraction. maybe a fraction more. Yep, that looks good. I can see that in a nice position. Close that part, edit the top part, because now obviously I have to put a groove in the top component. Now we have a unique feature when we're subtracting. We can subtract and create matching threads. Obviously there's no thread here, but I just subtract the foot from the base, and you can see I now have a nice matching groove. So I'll just close out and undo my isolate, and I've got all my parts back. Just nice and quick to work with. We've created that. We also need to add a groove into the bottom of this to fit the silicon foot in as well. So how am I going to go about doing that? Well, for start, I'm just going to isolate those components so I'm not trying to fiddle my way around. I can see my components nice and clearly, and I can just create, edit this part, and I'll use the subtract command again. Remove that part. Then I'll just simply clean this up, hide the other components with just Control Q, nice and easy. I just want to project onto this face, zoom in a little bit closer. I just want to turn on wireframe. We've got all these viewing modes possible. I just want to project this edge, and then I will cut that edge through the part. So I'll extrude just the edge. Make sure I'm using a subtract, and I'll do the subtract in both directions just to make sure. And so now I've got a hole perfectly sized to fit that silicon washer, or silicon foot I should say. So we've completed a lot of assembly design. We'll just switch back to the PowerPoint. You can see we've done design in context. I'll come to eliminating interference. We've got some more to do on that. And editing parts and creating parts to fit in context. We obviously also need to create part drawings. So we need to communicate the design of parts. I'm just going to pick, for example, this chain link. Simply right click on it and say create a drawing. Select my main views, and I can have them shaded or not as needed. And I might want to make this one just a little bit smaller. That's a bit better. You can see how my views all stay aligned. And I can simply retrieve dimensions directly from the 3D model. Now, I can also arrange these dimensions according to a predefined spacing, and that just makes it nice and basically quick to clean up and put the dimensions exactly where I want them. So I've now done that, and I want to add some additional dimensions that maybe weren't explicitly defined in the model. They're still from the model though, and I can create alignments and do all of that kind of stuff. So there's a couple of dimensions. And we may need one or two more dimensions. So I'll just add the last of these that we need. Now notice I can not only specify the type, but I can also specify things like prefixes, suffixes, and these can be carried or copied over from not just one dimension but other dimensions as well. So we'll just save this document and notice that it takes the name from the part file itself, and you can set it up so that it fills in all of your details. It's done. So you can see there that we've got very fast view creation, automated production ready drawings, and it's clear and accurate to the standards. So we've got to do one or two more little things in the assembly design. We maybe want to have a look at eliminating interference. So I'll just switch back to the assembly, and this part that we just drafted, while it's good in some scenarios, like around this corner, if we've got a tighter bend, we may need to look at interference. Now I'll just confirm that there's no interference there, that's okay. What about in this really tight corner? So I'll go back, I'll just check around this corner to see if there's interference. Okay, you can see that there is interference right in the corners there as we're moving. I've got various options. I can hide parts that are not interfering at all, and you can see that it just limits to only showing you the parts that are interfering and highlighting the interfering volume. So we need to do a little bit of work on this part. I can simply grab that face. Notice the dimension highlights because it's attached to it. And then I'm just simply going to rotate this face. I want to rotate it by about 5 degrees maybe. So I'll type that in. It's not letting me rotate, and the reason is you can see the coplanar relationship was stopping it from rotating. We don't want that to be coplanar anymore, and we want to be able to increase the angle. Now I can just keep on increasing that until I've got a nice little bit of clearance, which that looks about right. So now I've got my clearance, my dimensions changed. I'll be right with that. So now I've got a nice clearance all the way around this bend, and I can just double check that I have no more interference, which it confirms. So I'll just save my model, and we might need to have a look at modelling another part in the context of the assembly. We want to look at this electronics area. Now we've got a component here which is just a series of electronic boards all modelled together. We need to enclose this in maybe a sheet metal box of some kind, but let's just have a bit more of a look at it. You can see that if I look from this end, it's actually going to have interference, if it hasn't already, with the cable chain. I'll use my quick pick to select just the assembly that it's in, and then I may need to reposition this component in the assembly. So I can just use my steering wheel, and I'll rotate it around maybe 90 degrees. But obviously now that I've rotated it, my bottom mounts aren't in the correct position anymore. So I need to be able to see the other components in the assembly. So turn that on, and let me just position it. Might want to bring it over a little bit more to just give it a little bit more room. But before I do that, I want to position it accurately. So I'm just going to move the steering wheel. So we've got that on the edge now. Just move the component over. Oops. Looks like I might have not clicked on... Oh, I didn't activate the bottom part. move that over until it lines up with this component. Now we just want to move it forwards till the front edge lines up as well. And then what we'll do is we'll rotate it around and just make sure that the other support also lines up. So we've got to put it on the component. Notice. There we go. So that's now in the correct position. I'll just show the other components. Oops. Didn't actually get that right before. That's now correct. So it's now in the correct position. Show all my other components. I've got plenty of clearance all the way around. So now I just need to make my support or my enclosure to fit. So I want a couple of different components all in my selection. I'll just isolate them. And I'll go and create a new component in place. I can select aluminium as its material. I'll give it a name, a document number and a title. That also fills in the name because I have unique documents, and it adds the revision into the document number, into the file name. And I'm just going to switch to the part environment because I want to show you another way of creating components. Basically, I want to be able to enclose an entire body. So I'm just going to create very, very quickly and easily the body that I want to enclose. Just move the bottom up a little bit, and I'll actually just snap that onto the edge of the bottom enclosure. That's the correct note. I'll just bring that out to enclose the circuit board. Bring this one out to enclose that part of the circuit board. It looks good. I might need to just bring it a little bit further out this way. So it now completely encloses the circuit board. And there's a couple of little those foot mounts poking out the bottom. That's okay. That is about the size that I want it. So next I just come in and I say that I want to actually convert this whole body. But before I do it, I should actually add some clearance. So I'll add clearance onto the sides I want clearance for. Specify how much clearance I'm adding, and I may even move this face back a little bit so that that connector will poke out from the enclosure. So I specify that. That's all good. And I'll simply come and convert this into a solid. I can specify the corner treatment before I've even got any sheet metal, and I can specify all my various options. Then I just say where I want the folds to be. Okay, that looks reasonable. I've got a 2mm clearance and I've got a 1mm wall thickness. I'll just make that thickness inside. So I've still got a 1mm clearance all the way around this component. Now I may want to add some flanges. These should just be partial flanges. Not sure if I want to do them from the side. Let's have a look at that. Now I might actually bring these in from the ends instead of the side. So just undo that, and I'll bring the flange in just by maybe 10 millimeters, and I'll bring one in from the other end as well, same distance. But I've obviously got to provide room to not crash into all the different bits. So I'm just going to subtract from this body the previous one. Now I've got to make that into, I've got to select the faces I want to use. See, using quick pick again allows you to select accurately the faces that you want. So that's all bits of that one. In this case I'll grab the whole body, and I'll do the same for the other foot, and then now I can use my subtract command. Subtract from that body this one, cut out the hole, and I just want to subtract these feet from the base. And what you can see there is I end up with a part that will actually, oops, I may have slightly messed that up. I subtracted them from the wrong body. So let me just go back and fix up where I'm subtracting them from. Leaves me with a little sort of pip. I can simply delete that. And I obviously still need some clearance on these parts because we don't want it to be a completely snug fit. So again, I just want to offset all of these edges by the clearance amount, maybe half of it. So now I know this part fits, it's a snug, complete fit, and I'll just have a look at it in the context of the rest of the assembly and confirm that it's how I want. Now that looks good. Sorry, I should also do a flat pattern of it, and that way I can draft this as well. So, see, I can generate a DXF from the flat pattern in all the different AutoCAD formats. That just gives me easy machining of this component. So now I'll turn on the other bits. Make sure I've got that one turned on. And, oops, where's the rest of the assembly? Must have hidden it. Show it all. I can now see I've got a nice clean enclosure that fits nice and easily into my body, into my assembly. So I'll save that and we'll proceed. You can see there that we've done various, top-down design, assembly fit function validation. We've now got to do some drawings. We'll create a parts list. We'll show you one way you can share the drawings with non-solid edge users, and we'll show you how you can manage revisions. Now we switch back to the drawing. This has obviously changed from when we angled the face before. You can see the line around it tells me that the drawing views are out of date. I actually just want to add an extra dimension here, and this will just show you what happens. So you can dimension to intersection points as well. This will just show you what happens when I go to change a drawing or a drawing view. And now I want to update this drawing. So I just hit update, save everything as well. And notice this is telling me now exactly what dimension has changed, what the previous value was, and what the current value is. So I can copy this notation, all that information, and I have a revision table, and I can just edit that and paste the information in, and that gives me a full record, very simple way of tracking my revisions. So it makes it very, very simple. So next I need to add some extra views, and I want to add, the sheet metal part that I added. Type it in, make it a little bit smaller so I can actually fit it into the page. I can select predefined views, or I can select custom views. It's entirely up to you which way you go. I'll rotate this round and then just click on that. That orients my primary view, and I can just add additional views in here as well. Gives me a rough idea. I can place my views, and I'll just delete that one, and that'll give me room to add a flat pattern view. So I'm just generating the flat pattern, and I'll add the bend table, which gives you the up and down according to the view that you've specified. And I'll just go and add these dimensions so that I can see nice and clearly. You see how I can align these dimensions, just keeps them all aligned, makes it nice and quick. We also might want to do an assembly drawing, because let's face it, we need to be able to document the entire process. So I select my assembly. Now I can just scale it as needed and place my view. It goes away, generates the view, and maybe I don't want it to be shade or hidden edges. I'll just change it to be fully shaded view. Gives me a little bit more appreciation for what's actually going on. And I'll need a parts list for this drawing as well. So I just tell it that I want to place a parts list. I can do all sorts of things. I can save parts lists. I can change what I want to display in the parts list. At the moment it's top level components only. I can do atomic lists for ordering parts off. I can do assembly or assembly indented lists. But as you can see, for this particular assembly, that's a rather large list. If you need, you can set the parts lists to be created on their own sheets, but I'll just go for a top level list at the moment. Next, you'll see how you've got the item counts. I can move them around, and they just push each other around in order to maintain their alignment. I can select them all and get rid of the item counts if I want. I can add additional balloons. Here it is, and for example I'll link that to the parts list with the item number. See, so I've got the flexibility to do whatever I need to do to create the documentation I need. Now I probably don't really want in my columns the author, so I'll delete that, and I might go and add the material, for example. I've only got a couple of components in this particular assembly with materials assigned, and just shows you how quick and easy the documentation process is. So I'll just save this, and notice I don't have to just save it as a solid edge file. I can save this for tablets. Now, tablets are only one option for saving this into a portable document file. It's a very small file that can be emailed, and I've got various options as I save it. And that's one method. I can also create what's called package collaboration files, which allow the recipient to respond and send you markups and things like that. So there are actually a number of free tools with Solid Edge for all that kind of integration. So that's a quick overview of the assembly and design side of things. We can also do simulation. We don't really have time to do that today, but this allows you to virtually test to ensure required strength and or deflection, things like that. And it uses the world-renowned FEMAP with NX Nastran, quite a high-level simulation product. We've also got design management tools, much more than we've been able to show you today. And these allow you to navigate design projects, find files and links between files very quickly and easily, and make revisions and search where parts are used very effectively and efficiently. It also enables teamwork from a single source, so you've got full integration with different teams that you're working on. Now, Solid Edge also has quite a high level of rendering capability. You've got still images through to your simulation results, all the way through to, for example, motion check, simulating the entire range of movement of an object. And you can see our component there moving around. And it even covers simulation of little things like the length of the cable as it wraps and unwraps from the spool there. And you can see we've got different colours of product there as well. So I hope you've seen Solid Edge with synchronous technology giving you tools to accelerate your design, the ability to make faster revisions and reuse components that have already been designed. And that just all comes down to getting your products out the door faster. There's a couple of quotes in there as well if you want to have a look at them. So we'll move on to a questions and answers time. If you have any questions, please just use the questions pane and we'll attend to them as soon as possible. If you have more questions and want more information, please contact us. You can use either our phone number 1300 883 653, or you can email us for information at info@edgeplm.com.au. So thank you everyone for watching, and we'll just move into the questions and answers time now.